Okay, in solution thermodynamic under the subtopic of molecular attraction, okay, we'll see liquids and solid. It is have different from gases in terms of the molecular attraction. So the molecules of the liquid or solid are held together by a certain amount of intermolecular thickness. So for a solution to occur, the solvent molecule must overcome this intermolecular thickness in the solute and find their way between and around the solid molecules. At the same time, the solvent molecule themselves must be separated from each other by the molecule of the solid. So this is accomplished best when the attraction between the molecule of both components are similar. If the attractions are sufficiently different, the strongly attracted molecule will cling together, excluding the weakly attracted molecule and immiscibility, which is not able to be mixed, which is two separate layer, okay, will be resulted. And oil and water do not mix because the water molecules strongly attracted to each other will not allow the weakly attracted oil molecules between them. So it is an immiscible. Solubility of polymer largely determined by its chemical structure. And solubility parameter is a numerical value that indicates the relative solvency behavior of a specific solvent. Polymer will dissolve in solvent with solubility parameters are not too different from their own. So we use term like dissolve like. So structural similarity favors solubility. So like dissolve like means that it have a similar chemical groups or similar polarities. Okay, networks and swelling. Small molecule can dissolve in a solvent very quickly, whereas a polymer would dissolve in a solvent much slower. So the larger the molecule weight, the larger the molecular weight, the more difficult for it to dissolve and a longer time is required. A polymer molecule can be represented as a long flexible chain, not rigid but can be easily bended. So putting many chains together, they would tend to entangle with each other. So this physical entanglement gives rise to the exceptional physical strength of polymer over other materials of lower molecular weight. So this is consistent with the fact that lower molecular weight polymer has weaker mechanical strength because shorter chain form less entanglement. Very short chains cannot tangle with each other and hence they do not contribute to mechanical strength. In fact, mixing shorter chains with the longer one can reduce the chance entanglement between the longer chains and hence weaken the mechanical strength. So hard plastic such as PVC could be plasticized by low molecular weight compound like DOP to become soft and flexible. Okay. So process of dissolving polymer. A solid polymer sample can be considered as an entangled mass consisting of many polymer chains. So the action of the solvent is the solvent molecule will slowly diffuse into the polymer mass, causing it to swell. So if the attraction forces between polymer molecules are very strong, such as due to cross-link or hydrogen bonding or crystallization, then the solvent molecule will not be able to separate them far apart. And a gel will form, but not a true solution. Okay. For example, the vulcanized rubber or PE in the toluene. However, if the attractive forces between solvent and polymer are stronger than those between polymer chains, the swelling continues with more and more solvent molecule diffusing into the polymer mass, and the polymer chain gradually disentangle, moving away from each other until they are free from each other in a dilute solution. For example, PMMA, PS, PVC. Okay, sebenarnya dia akan jadi dissolve lah Okay, kalau yang ni dia tak dissolve dan dia jadi swell. Okay. So the relationship between polymer properties and solubility. First, in terms of cross-linking, prevent the solubility in the polymer. Kalau material tu cross-link tinggi, so dia tak boleh nak dissolve lah. Okay. The polymer do not dissolve in any solvent but swell only to limited extent. So if the polymer has high crystallinity, crystalline polymer often soluble at temperature above their Tm or in strong interaction solvent. So PVC, PEO, PAA with polar pendant group are soluble in water, while polystyrene, polyolefin, it dissolves in hydrocarbon solvent. Nylon, which has strong intermolecular and hydrogen bonding, it will dissolve in interacting solvents such as phenol or concentration of sulfuric acid. Okay, in terms of the molecular weight, as molecular weight increase, the solubility of polymer will decrease. Means that it hard to solute, it hard to soluble in the solvent. Okay, habis.